So now let's look at the right side of the periodic table. So for the group 17 here, they are known as so-called halogens. It is because they have a tendency to form a various kind of the salt. And for the group 18 element here, they are the so-called noble gas because it is not because they are more important than others. It is because they are lazy. They are the unreactive gases, and they tend to not to combine with any other one else, which means they try to isolate from others. So the chemical interaction with other elements is actually very low. So this reason they are the so-called noble gas. So you can see now that the name for each group has the historical and physical reason for that. And now let's take a look about the group from the 13 to 12. So they are all the metals, but they do not form the alkaline solution with the water. And these metals tend to be harder than the alkaline metals and less reactive with the water. So they are used for constructional purpose. So collectively, they are known as the so-called transition metals, as the 6 elements we just introduced you there, like the silicon. But now this transition depends on the property. The silicon is the transition from metal to the non-metal, and here it is the chemical interaction, the property from interacting with the water and less to the water, and eventually they don't like to interact with anything. And the other reason for this kind of transition metal is because that they are actually in the center of the periodic table. And among these transition metals, we have several famous and popular names we already definitely heard before, like irons, silver, and gold. They are all those the so-called transition metal here. Finally, for the period 6 and 7, you will find out they have 2 different kind of the so-called inner transition metals. So unlike the period 4 and 5, it seems they have extra elements here. And what are these subset of the 14 metallic elements? So the first set is the atomic number. If you don't remember the atomic number, please go back and check the definition. It is from the 58 to 71 for the period 6. And this one, for the period 7, the periodic number is from 90 to the 103. And it is the so-called inner transition metals. And people find out if you try to insert these 14 inner transition metal in the main body of the periodic table, it will make it messy and hard to identify the information and property we want. So this reason we just try to insert them and put it that below the periodic table. And now let's try to focus on this 6 period inner transition metal. So they also have a particular name for that. It is so-called lanthanides because they follow after the lanthanum, the property here, the first property, lanthanum. And because they all have a very similar physical and chemical properties, so they tend to occur mixed together when they are found in a mine or within some position on the earth. And also because they are so similar, so lanthanide are actually unusually difficult to purify. So which you mean, because when you find it, they are all together. So when you try to separate one by one, it is not an easy task because they all have very similar chemistry and the physical properties. So it is very hard for the human being to purify them. And the commercial use for the lanthanide has now, people find out they are more useful than we thought. So several lanthanide elements can be used, for example, in the fabrication, for example, of the light-emitting diode, which is LEDs, of the computer monitors and the flat screen televisions. So that is one of the reasons now people now have to spend more time to develop the technology, how to purify the elements for this particular group. And for the seventh period of the inner transition metal, they are the so-called antonite. So because they are following after the element and the actinium here, so they also have a very similar properties and hence are very hard to separate. And for this particular one, they are most useful for us to build a very dangerous weapon, the nuclear weapons, or when we use the nuclear fusions. So nuclear power plant in power industry actually have the difficulties because that they require to purify the samples for almost from two of the most public antonites, uraniums and plutonium, and the technology how to separate them and purify the uranium is the main goal. Try to this is the main element we are going to use for the nuclear fusion, the fusions. So they are very useful actually in our daily life. And actinides are actually heavier than the uranium and are not found in the natures, but they can be synthesized in the laboratory. So this is related to the property I mentioned a while ago in the previous chapters, that not every element here in the periodic table can be found in the nature. Some of them doesn't exist. You should synthesize that in the laboratories. But still, based on the atomic number, atomic mass, the size, the physical property, and chemical property, now people can combine all these elements in one tables. So you will see that there are so many information you should know and remember when you are given the periodic tables. So this is the end of the lecture. Oh no, actually, we are going to continue our discussions for the other topic about the physical model and conceptual model soon. So before we study the physical and the conceptual models, we have to refresh one thing we learned in our previous lecture, which is that the atoms is ancient and empty. So do you remember the analogy I give you to use that if you treat that the nucleus, which is the center of the atoms, which is the size of a ping pong ball, then the electron is just a big bacteria. And if you try to bring the size to a physical model, you can see then the distance from the electrons to the nucleus in terms of the scale I just mentioned, the distance between them should be 1 kilometers. So now you cannot really see the atom itself. It is so empty and so small. So this is, and the other reason you cannot see that is because that when the light travels in terms of wave, the atoms is actually much smaller than the wavelengths of the visible light. And that is the light allows a human being to see. So when the visible light interact with the atoms, they will not be reflected. So if the light is not reflected by the atoms, there's no way you can see the image in your eyes. So the concept of the physical model is that it is either a very small, very large visible object. So they can be represented by a physical model, which is the ping pong ball. I try to visualize that. But intrinsically, atom itself is the thing you cannot see that. So physical model is a one which can replicate the object at a more convenient scale. So in the figure here, you can see that there is a large physical model of the microorganism that a biology student used to study the microorganisms' internal structures. But since the atom is invisible to us, so therefore we cannot use a physical model to represent that. We can use that the ping pong ball and bacteria, but not the true one. So in other words, is that we cannot simply scale up the atom to a larger size so that we might able to with the microorganisms. So in that case, the chemist proposed a so-called conceptual models. So what is a conceptual models? It describes the systems. So the more accurate a conceptual model it is, the more accurate they can predict the behavior of the systems. So here, this is the concept of this is the conceptual models, and this is the physical model. So this is the thing we can see, and it is visible to us. But this one cannot be visible to us. But chemists propose the conceptual one based on the interaction rate and the mass and all other different kind of property, and help us to understand the systems. So therefore, the more precise and accurate the conceptual model it is, the more accurately we can predict the interaction of the systems. So therefore, an atom, an object which is so empty, so small to us, you should definitely use the conceptual model to describe that. So even though we cannot directly measure the atoms, but we can use some indirect approach to detect or measure the properties of the atoms. And one of the most useful technique or the instrument is the so-called spectroscopic. And the principle of the spectroscopic is actually related to the concept of light, the reflections we study. So what they are going to do is they are going to measure the spectrons produced by the individual atoms. And after the light was produced, they are going to separate the light into the component frequency. But now the difference is that the frequency, the spectrum produced by the atom is not continuous like we have here. When you have the prisms, the light entering the prism, they are reflected. It is a continuous spectrum. Instead, the spectrum from the individual atom will be distinct one by one and not continuously.